on record, Mr. Morris.
No, it's on record.
Mike Johnson has beautiful teeth.
Oh, there you go. Now we know.
Mr.
Oh, you know what that is? But
Mr. Morris, what's the lattice rectum?
the lat.
It was
That's a mathematical term.
Okay.
it's, it's a lattice rectum. That's like the worst mathematical term in all of math. Basically, I believe that the lattice rectum. Darn near killed him. All right, I was waiting. Is the distance like that? It's a. If it runs through the focus, I believe the lattice rectum is the like this distance from edge to edge of your parabola slash hyperbola that runs through the focus and is perpendicular to this axis. I think that's what it is, but we don't really use it, so just ignore that. Can you imagine me actually teaching that to half my classes? They like wouldn't be able to handle it. He said rectum. All right.
No, and then there's be the one kid that says, "Oh, he said lattice."
All right. So this one, I've got a focus at -3/4. So definitely want to sketch a picture for this thing. All right. So I've got one at -3, 3, +4, 1, 2, 3, 4, and that's going to be a focus. Let's put in a focus color here. I usually use my focus as green. All right. So, and then the directrix is the line that is y equals 2. All right, so is that a horizontal line or a vertical line?
Horizontal.
Horizontal line, and it's at 2, so it's this. All right, so that's going to tell me is what kind of parabola do I have? Opening up, down, left, or right? Up, because it's got to wrap around this, and it's got to, and the vertex has to be in between these two things. So that's going to force my vertex to be right there. So already I know that the vertex is at -3, 3. All right, and I know that my parabola is going to do something like that. So that's going to help me get my equation.
So you don't have to find actual points.
Well, they want the equation of this parabola in this section.
Oh, but we didn't have to actually like figure out the like I don't know the actual shape of the parabola. We just had to draw like a shape kind of for it.
Yeah, it doesn't have to be perfect. Like when I say sketch a graph while you do these, I literally mean just sketch a graph. And the only reason is because it kind of helps you get oriented in which direction it's going, and it really straightens things out. So now I know what formula that I'm using because I'm using the going up, opening up formula. So is that an x squared type or a y squared type?
X squared.
It's an x squared type. So this is going to be x minus this x, which is -3 squared equals 4a. What's a here? That's the space between the focus and the vertex. 1. Y, which is y minus 3. X plus 3 squared equals 4 times y minus 3. Not too bad. Okay, 36 is the same idea. And again, I'm going to sketch myself a little picture. So this time I've got a focus at -4, +4. This is its focus out there. And then I have a directrix line at y equals -2. That's down here. Okay, so how many spaces in between there? 1, 2, 3, 4, 5, 6. So that means that my vertex is going to have to be 3 in between those. 2, 3. So it's going to be down here. So my vertex is going to have to be at -4, 1. And it's an open up again. Because it's got to go away from this line. It's not allowed to cross it. And it's got to wrap around the focus. All right, so it's an opening up type, so that's an x squared type. So we end up going x minus -4 squared equals 4a. What's a this time? 3. Y minus 1. So I get x plus 4 squared equals 12 times y minus 1. That's the equation of my parabola. It's getting a little easier. All right, now you got to do a little algebra before them that makes them a little trickier. Okay, first of all, is 51 going to be an open up and down or an open left and right?
Left and right.
Left and right, how do you know?
Because of the y squared.
Yep, it's a y squared problem. So I want to get everything that's not a y away from this. So we're going to move this over here. So I'm going to have y squared plus 2y equals x. Right? And then I want to complete the square. What am I going to have to put here? Yep. But if I add 1 to that side, I have to add 1 to this side. So now this is y plus 1 equals x plus 1. That's y plus 1 squared equals x plus 1. What's a? Let's do it this way. What's supposed to be here? 4a. What is there? A 1. So what's a going to be? So that's kind of annoying for my focus, I think. Because what did they want? They wanted everything for this one. Vertex, focus, directrix. Okay. So vertex, we can at least get that. Where's that one going to be? From here? -1 and then -1. So there's my vertex. And we know that this is an open side-to-side one. And my focus, now is it going to be an open to the right or open to the left? How do you know?
To the right because it's positive.
Right, because I don't have a negative 4a in here. Okay, so I know that it's got to open to the right, and my focus has to be 1/4 in that direction. So my vertex is at -1, -1, but my focus is going to be 1/4 that way, which means that that's going to be -3/4, -1. And then my parabola's going to open up like this. It's going to be pretty wide because the focus is so close. And then the only other thing that I need is a directrix, which is going to be 1/4 this way. So my directrix is going to be x equals -1 1/4, or -5/4.
It's really epic, right? It's a lot easier to see when it's like clear.
That's what everybody says. I think that it's because when we write with the other type, it's uniform. It's kind of weird. You guys are used to seeing like a whiteboard with a like a chisel tip marker, which doesn't look like that. So your eyes are expecting to see something that's not uniform with. So I don't know. You would think that it would make it look harder. But I think it's easier to read too.
I think your handwriting is really good.
Mine?
Yeah.
Oh my gosh, tell my mother. She used to say it was awful. All right, and then 54, similar. I've already got my x's and y's broken up. Is this a side to side or an up and down? Side to side. Okay, so I've already got the x's and y's broken up, so I just need to complete this one square. So it's going to be y squared plus 12y plus,
36.
oh my gosh, that's a large number. So I have to add 36 to that side, so that means I have to add 36 to this side. So now I've got -x plus 37. Yikes. Okay, well, this is y plus 6, y minus 6, I'm sorry, plus 6, so this is y plus 6 squared, equals, now what should I do with this? Definitely pull out a -1, leaving me behind with an x minus 37. All right, so where is my vertex?
-6, 37, 36.
Okay, So I've got that one now.
Wouldn't it be the other way around?
Yes, it would. And did I? No, because it was -1 up here. I couldn't screw that one up. You're right, because the x part has to come first. So it's actually 37, -6. You're right. All right, so then if I start sketching that, well, that's not fun. So I have to go, let's see, +37. And then I got to go 1, 2, 3, 1, 2, 3, 4, 5, 6, down this way. Is this one opening up? Well, we said that it was left and right, but is it left or is it right? It's left because it's negative. And what is the focus going to be? Because it's supposed to be a 4A, but it's a 1.
Negative.
So A, well,
Negative 1.
the negative just gives me direction. This is going to actually give me distance, so I want the distance to be positive. All right, so it's going to be 1/4 in this direction. So that means it's going to be at 36 3/4. 36 3/4, but it's still at -6. Okay, and that means that my directrix then is going to be at x equals 37 1/4. A little bit better? All right, I want to practice with these a little bit more over the weekend. I didn't give you very many. 20 through 55 multiples of 5, but obviously you've already done 30 and 45, so you don't need to do those. So I think that ultimately this is like maybe 5 problems, 4 problems. I don't know, it's not very many. 20, 25, 30, 35, 45, 50, 55. So it should be 8 minus 2, 6. 6 problems. All right, see what you can do with those.